Okay, hello everyone. My name is Michael Downey, Library and Information Services Coordinator at the AWRI, and it's my pleasure to welcome you to today's webinar, the third for the 2015-16 program. Now, our topic for today is soil health, and our presenter is Robert White, Emeritus Professor at the University of Melbourne. Robert has a long history in research and involvement in tertiary institutions around the world. Robert also has extensive experience consulting in a range of viticulture and soil projects and is the acclaimed author of several books. But before I hand over to Robert to tell us more about today's topic, a couple of notes on what you as the audience should expect. The format for AWRI webinars is a short presentation followed by a Q&A. This session is being recorded and will be available to view via the AWRI website. And finally, for those new to webinars, it's important to remember that webinars are interactive. So to ask a question when we come to the Q&A, please type into the questions section of your control panel in the bottom right corner of your screen. For those with access to a microphone, there is also the option of speaking directly with our presenter by clicking the raise hand button, which is located in the top left section of your control panel. If you'd prefer to ask a question via email, please do so at infoservices@awri.com.au. We are monitoring this inbox and we'll get as many questions through to Robert as possible. Right, that's enough from me for now. I'm now going to hand over to Robert to tell us more about today's topic.
Hello everybody. I'm going to give you a quick synopsis here of what I'm going to talk about. I'm going to try and define what we mean by soil health in relation to growing wine grapes. Say a little bit about research and advice on how to improve soil health, practical measures that growers might use to improve soil health, and then some comments about measuring soil health, what tests are useful and what are not, and any of the practices which are detrimental to soil health. So in thinking about soil health, we should, I believe, take a holistic view and recognize that soil health encompasses the soil's chemical, physical and biological condition. And it really relates to the soil's fitness for purpose in growing grapes. Now, these chemical and physical biological properties determine soil health, depend on what I call a set of inherent factors and another set of dynamic factors. Let me explain what I mean by this. Firstly, the inherent factors. Now, these are things that obviously one generally inherits. You can't do much about them. The parent material, that's the geology of the site, the climate, the rainfall and temperature, the organisms, mainly vegetation under which the soil has formed, the topography, the up and down of the site, and the time for which the soil has been forming. In other words, its aging process, and we all know something about that. Let me give you some examples of these inherent factors, how they affect soils formed either in situ, that's in place, or formed on transported materials. Looking firstly at the slide on the left, a deep red loam formed on dolerite rocks in the King Valley of northeast Victoria. This has been used for viticulture, growing grapes there by Brown Brothers and others at a height of about 800 metres. And then we have another soil on the right, a red dermisol formed on basalt, another basic rock on the Mornington Peninsula, which shows, in both cases, a very uniform profile going from the surface down to the subsoil, and these are deep soils so that vine roots can penetrate quite deeply. Then by contrast, on the right-hand side of this screen, we have an example of an infertile podzolic soil formed on old sandstone rocks. And there's plenty of old sandstone parent material around southeastern Australia. And you can see that this is a pretty poor soil. It's deep, but very sandy, bleached, and doesn't contain much fertility at all. Not widely used for grape growing, I might say. On the other hand, on the left-hand side, we have a terra rossa formed on limestone, the classic iconic soil, I suppose, of the Coonawarra region, where we have these red dermisols of variable thickness overlying a calcrete layer which is on top of the ancient limestone. Moving on, we have again on the left-hand side another soil formed on limestone, this time in the Hunter Valley. There isn't much limestone in the Hunter Valley, but where it does occur, it forms this rather desirable soil, which as you see is fairly deep, up to 60 centimetres before you start getting into the subsoil, but with a very good structure, well drained and well structured. In contrast, on the right, we have soil in the Marlborough region. This is relatively common there in Marlborough in New Zealand, where these gravels have been washed out during the last ice ages and deposited a very heterogeneous mix of gravel and boulders with a thin soil on top of it. Now, this is obviously well drained, but very low in nutrients. On the left-hand side, we have another example of a rather unusual soil. You see there's alluvial sediments in the Riverina, which are quite extensive, but they overlie an ancient weathered soil called a laterite. And this laterite goes back millions of years into the tertiary, but the alluvial material has been washed out over the plains from the mountains in relatively recent times. And then another contrasting soil on the right is this colluvial shale deposit, where it's showing very little profile development, lots of fissile shale material, and quite well drained, but again relatively low in nutrients. So one sees from this brief pictorial journey through these soils that you can get enormous variability in the kind of soils which form in various parts of the world and which have been used for growing grapes. Now, moving on from these inherent properties, which, as I said, you can't do a lot about, onto the dynamic properties that also are very important as far as soil health is concerned. And I've listed them there, these properties that affect some process in the soil. It might be decomposition of organic matter, could be water retention, drainage, could be mineralization of nitrogen. And I've listed them as soil structure, organic matter, soil pH, nutrient status, salinity, and possible toxicity. These are by no means an exhaustive list, but they are some of the more important dynamic properties, which, as the name implies, can change quite quickly, and they are susceptible to management by the grower. Now, looking at these dynamic properties, a project funded by GWRDC that I was recently involved in, we developed a minimum data set for these key soil properties that might be used as indicators of soil health in the vineyard. and tried to establish what the threshold values or optimum ranges for these properties were, which would enable growers to actually benchmark their soils against what was considered to be an optimum, or not to let a particular property value fall below a threshold. And these results were published in the Australian Journal of Grape and Wine Research recently, and also there was a more popular article published in Wine and Viticulture Journal in 2014. Now, just briefly describe this minimum data set. I won't dwell too much on all the details, simply to say that looking at the top 15 centimetres of soil, there were two physical properties that were considered to be important for benchmarking: the stability of aggregates and the air-dry consistence of these aggregates, which really means the strength of the aggregate, how easily can it be broken down. And then there were some chemical properties. Soil organic carbon was one. Sorry, I slipped through there. Going back to the chemical properties, pH was important because it controls the availability of a number of the micronutrients, amongst other things. Electrical conductivity, which is a measure of the salinity in the soil, and the chloride content, which is also a measure of the likely damage that might be caused by too high a salt content. Other chemical properties, cation exchange capacity was important because this is the way that the cationic nutrients are held, and the exchangeable cations themselves. What sort of ratios did they occur in the calcium, magnesium, potassium, and sodium? So you can see that there's some benchmark values inserted there. Now we go on to the biological properties. Three of those were recognised. Soil organic carbon was obviously one. Soil microbial biomass was considered to be very important, and potentially mineralizable nitrogen was also important. This is a measure of how quickly organic nitrogen in the soil can be mineralized to produce ammonium and nitrate. So those were the key properties of the minimum data set. Let's see how one might go about trying to attain these optimum values through a combination of these chemical, physical, and biological properties. And the sort of things that can be acted upon are the use of soil amendments. I'm sure many are familiar with lime for raising pH, gypsum for correcting sodicity in soil, and of course the fertilizers themselves, provided the fertilizing strategy is combined with a soil or plant testing regime to determine what might be deficient or what might be in excess. Use of cover crops, very important from the point of view of soil structure, and then compost, manures and mulches, which are very important from the point of view of supplying soil organic material and stimulating the microorganisms in the soil that are important for nutrient turnover and various other functions as well. So let's have a look at a few examples. We'll start off with soil structure, and I'll just show a few slides of soils which had very desirable structure through natural processes. The one on the left is in the Mâconnais region in France, which is, you can see the ideal crumb structure. There's fragments of stone there. It's well drained and allows good root penetration. In the middle, we've got crumb structure of a calcareous soil in Tuscany. You can see that these soil crumbs, as we call them, the aggregates, are of the order of 1 to 2 centimetres in diameter, and that gives you a stable soil structure for accepting rainfall and resisting erosion. And then as far as the subsoil is concerned, on the right-hand side, an ideal prismatic structure such as we find in the deeper examples of Terra Rossa in Coonawarra. You see that they're quite large aggregates, but they're separated by pretty well-defined pores, fractures, cracks, and within the aggregate itself, that's where the water is stored and slowly released to the vines. So talking a bit more about cover crops now, one can increase soil organic matter with cover crops, and grasses are better from this point of view than legumes. They can be used to reduce excess vigour in vines on fertile, well-watered sites. They provide better trafficability of the mid-rows when the soil is wet, that is, the soil strength is better, and they can reduce compaction, which gives a larger non-limiting water range. Now let me just explain quickly what that is. This is really the amount of water which is available to the vine, and it is limited at the lower end, that's on the left-hand side. If the soil strength is too high because the roots can't penetrate, and if the water is held at too high a tension, the roots can't extract that water. The upper limit is the drainable limit, where the pores are filled with air. Now, a large non-limiting water range is good, but as the structure declines through compaction, you'll notice how the soil strength becomes too high on the left-hand side. You lose porosity, so that the overall air capacity decreases, and the result of all this is the non-limiting water range will decrease. And that's an undesirable trend which is associated with a decline in soil structure. Now going on with cover crops, mixed species cover crops can be very desirable because of increased biodiversity and the promotion of beneficial organisms which might be valuable for biological control of pests, such as parasitic wasps or predator mites. Now, just to give you an example of what a cover crop can do, this is a vineyard on a black clay soil in the Geelong region, and normally these black clays are difficult to manage, but under this permanent cover crop, which was complete under vine as well as in the mid-row, you can see that a very desirable structure has formed with plenty of relatively small aggregates, meaning that it's going to be well aerated but also well drained. I mentioned the mixed species cover crop, which are quite popular in organic vineyards, and this is one on the left, is at Antarangi in Marlborough, New Zealand, where they have broadleafed and grasses and so on, quite a variety of species there. But then another example of a value of a cover crop is in establishing a new vineyard on sloping land, such as in Stellenbosch in the Western Cape, South Africa, where the cover crop can stabilise the soil against erosion when the soil is bare. Now, building up soil organic matter, which is what cover crops can do, and manures and compost, but it does require a lot of or large inputs of organic materials and can be slow, particularly in hot climates and on sandy soils. And I'll give you an example of this from France in the sandy soil in the Loire Valley, where they carried out an experiment with composts and manure over 28 years on a soil which was originally very low in organic carbon. You can see that 0.6%. And over this time, through adding quite large amounts, up to 20 tonnes per hectare per year, they've managed to double the organic carbon, which is it's a good result, but it's obviously taken a lot of organic matter and a lot of time. And note that the extra available water in that second column is not particularly large. When you think of 30 centimetre depth of soil, you get an extra 7.5 millimetres of available water, which might simply be evaporated or transpired within a few days, hot days in the summer. Organic matter can also stimulate the soil microorganisms because it's providing extra food for them. And an example of this is the organic versus conventional viticulture on limestone, the top two rows. You can see there that they've been going for 34 years, added quite a lot of compost, managed to increase the soil organic carbon, yes, but the significant effect, I think, was the increase in the microbial biomass carbon, which gives you an indication of how active the microorganisms are and how fast the organic carbon in the soil can be turning over and producing beneficial compounds and releasing nutrients. Here's an example from closer to home in the Hilltops region in New South Wales, where the grower put on composted straw and pig manure onto a degraded granitic soil, very large application of 100 cubic metres per hectare. And one can see that this has broken down very quickly, and it has also made the surface of that soil friable and well aerated. Examples of a mulch which can be beneficial in vineyards, such as in the Barossa Valley on the top left-hand corner. The benefits of mulch are that you get a build-up of soil organic matter. It encourages earthworms because it keeps the soil under the mulch moisture, and the earthworms like that. Here's another example from the Hill of Grace vineyard in the Eden Valley, where they use compost extensively and mulch, and they use also cover crops, and one knows that they produce very good wines. Here's an example of actually making that compost from grape mark, manure, soil and lime, a time-consuming process, but nevertheless in the end you get benefits, and you can see the compost on the left-hand side there under the straw mulch, where it is protected to some extent and doesn't decompose too quickly. Now, some of the other practices which are advocated in building up soil organic matter or increasing microbial diversity, there are various biofertilizers on the market, humates, seaweed extracts and so on, compost tea. The general comment I'd make about those is that they're low in macronutrients. There are claims made for these compounds providing growth regulating compounds to the vines, but these are to some extent subjective, and they don't necessarily supply micronutrients. They also may be expensive for what you're trying to achieve, and because they're applied in relatively low concentrations, you may not get much effect on microbial populations or nutrient availability. This brings us, of course, to biodynamics, where we have the preparations 500 to 508. These the biodynamics are becoming more and more popular, certainly, but research in the United States, for example, has shown that yes, they can increase soil microbial activity and microbial diversity, but there was no consistent effect on grape yield or wine quality. However, recent work in Australia in the McLaren Vale has found that organic and biodynamic systems do improve the soil biology, but the important proviso is that compost has got to be added with the biodynamic preparations to provide the organic matter. They found that generally the grape quality was better, but this was compensated to some extent by lower yields and higher costs. And the reason why the BD preparations themselves can't be expected to do a lot on their own, that is without large organic matter inputs at the same time, is that they're applied at very low rates, such as 100 grams per hectare. And if you think about it, the competitive pressure of these organisms in that small application with the bugs that are already in the soil microflora itself, the competitive pressure is so great that the odds of them surviving any length of time are very low, something like 1 to 25 million to 1. Now, biological tests, these have become much more popular in recent times. There's a range of them available from commercial laboratories. Microbial biomass carbon is the best one, but trouble is that as done by the Chloroform fumigation technique, it is a bit tedious, so the laboratories are now looking at alternative methods of getting an estimate of the microbial biomass. Potentially mineralizable nitrogen is also fairly tedious. As we go on, you see there's the opportunity for microbial enzyme assays. Active carbon, which is relatively easy to measure, is okay. And more recently, a lot of interest in genetic profiling to work out the genome in the soil of the soil microorganisms. But these tests, generally speaking, have not been related to any soil function, and very few have benchmark values. However, the website www.soilquality managed through the University of Western Australia is trying to assemble some of this information for 4 wine regions in Australia. One problem I would stress is that, and this applies to all soil testing, whether it's for biological properties or chemical, physical, is you get variability between different tests for the same property, and this is particularly illustrated by measuring microbial biomass carbon. You can get variations between laboratories for the same test, and you can get miscalculations. And this set of data here shows that you can get quite a range of microbial biomass carbon values depending on the method of measurement. The subscript or superscript 1 is indicating the substrate-induced respiration method, whereas the more valuable test is the carbon chloroform fumigation test, which gives you a much more realistic value. However, as I said, it's tedious and expensive for commercial labs to use that test, and they're looking for suitable alternatives. But the take-home message is, if you're going to have soil testing done, go to the same laboratory every time and make sure they're using the same test for the particular property you want measured. Now, to finish off, some of the practices that are not good for soil health. One is excessive cultivation of the mid-rows, and there's an example of that from the Medoc in France, where they're very keen on cultivation, keep weeds down. Then in the Hérault region of France, mid-row cultivation there has caused compaction, and as you see, the vines have suffered in some cases. The other thing about bare cultivated mid-rows is that they can be very prone to erosion, such as you see in the top slide on the Côte d'Or in Burgundy. This is the lower slopes of the Côte d'Or, of course, where there was a heavy thunderstorm in summer just before I passed through there, and you can see the wash of soil down the slope. Then, of course, overcultivation will produce a kind of soil, as you see on the right-hand side there, and the right bank of the Gironde in the Bordeaux region, where excessive cultivation of a sandy, gravelly soil has more or less removed all the organic matter from that soil. So that's very bad for soil structure. Other practices bad for soil health. Too much nitrogen fertilizer as urea or ammonium nitrate through the drip line can cause soil acidification. Overliming can cause micronutrient deficiencies, particularly of things like iron, zinc and copper. Saline irrigation water can be a problem. Now ideally it should be less than 800 EC, but that's about 500 parts per million, but even less than that is better. And the problem can be that you can create, from the sodium that's applied in the irrigation water, you can create a sodicity problem, which is bad for soil structure. Over-irrigating can be a problem through a possible rise in the groundwater table. Excessive spraying with herbicides and fungicides can be bad for the soil biology, the soil microbes, and not returning enough organic residues to the soil, of course, is bad from the point of view of not sustaining that soil organic carbon, keeping the structure of the soil in good shape, and keeping the microbial population in good shape. Then finally, just to summarize, I'd say good vineyard management from the soil point of view depends on optimizing the nutrient supply. Now this can be done through fertilizers and sprays, coupled with soil and plant testing ideally, the development of a good soil structure, and that's associated with gypsum if you've got a sodicity problem, or lime for pH, and cover crops bringing in organic matter. And in addition to those cover crops, you can provide good inputs of organic matter through compost, manures and mulches, which will encourage the soil biological turnover. This is good for nutrient cycling, but it's also good from the point of view of nutrient turnover, mineralization and so on. So finally, if you want further information, more detailed information, then I've got the second edition of my book, Understanding Vineyard Soils, which came out earlier this year. Thanks for that.
Okay, thanks very much for that, Robert. Well, from here we'll move straight into a Q&A, so please start sending in your questions. Just a quick reminder, for those that have a microphone and want to chat directly with Robert, please click the raise hand button. For those that want to type your questions in, please do so in the questions section of your control panel. Now, Robert, your screen is still broadcasting there, so just be aware of that. I'm just sending you through a question now, Robert.
I've heard that increasing the carbon content for a soil type by 1% will double the water holding capacity. Is this true? Well, I assume this is an increase in organic carbon from, say, 1% to 2%. But as we've seen from the work that was done in France, for example, on a sandy soil, where they doubled the carbon content from 0.6 to about 1.2, this increased the available water by 7.5 millimeters in the top 30 centimeters. Now that would hardly be doubling it. It would be probably a 10 to 20% increase maximum. And this kind of result has been found in other research which is done in other parts of the world. So the claim about doubling water holder capacity is generally exaggerated. Why are grass species better than clover legume species for increasing soil organic carbon as a cover crop? Well, the point about legume species is that they're fairly high in nitrogen, and so when they're in the soil or cultivated into the soil, they decompose quite quickly. This is good from the point of view of releasing mineral nitrogen, but it doesn't add a lot to the soil organic carbon. Whereas grass species have lower nitrogen content, they are much slower to decompose than a succulent legume crop, and hence as they slowly decompose, they will add to the soil organic carbon, particularly the humus content of that carbon. Third question, can one put too much compost, say straw or sawdust, down between rows? Yes, one can put too much of that kind of compost, because straw or sawdust has a very high carbon to nitrogen ratio, so that it's slow to decompose, but as it decomposes, it locks up nitrogen, mineral nitrogen, so that the long-term effect in increasing organic carbon in the soil can be good, but the short-term effect of locking up nitrogen that could be used by the vines and the cover crop itself can be a disadvantage.
Okay, that's all we've got at this stage from our audience, Robert. We'll give it a little bit longer and see if any final questions come through. Before we wrap up, is there anything that or any comments you want to make before we start to finish? Anything?
Well, just to reiterate my my final comments about managing the nutrient supply through, but particularly important to do some soil testing or plant analysis. Plant analysis, tissue testing is much more effective for determining whether you've got a micronutrient deficiency or not. Soil tests are not so good for that, but for the major nutrients like phosphorus and sulfur, potassium in particular, soil tests are valuable. And then there's the importance of maintaining the organic inputs into the system, into the mid-rows as well as under vine, to improve the soil structure, which is very important from the point of view of rainfall infiltration, drainage through the soil, getting adequate aeration to the roots, as well as providing a food source for the microorganisms that are busy decomposing organic matter and probably providing some valuable growth regulators to the plants. But we don't know so much about that part of it. Another question's come in. Can you make comment on wine quality relative to compost use? Well, only from the point of view of work which has been done, as I said, in North America and Washington and Washington State and California, where they did various trials with compost and looking at fruit quality and wine quality. They found that the results were inconsistent, in that some cases there was an improvement and in other cases there was not an improvement. But perhaps more positive was the work that was done in McLaren Vale by Luke Johnson and his co-workers, where they did find that there was an improvement in wine quality as assessed by sensory tasting, a sensory tasting panel, for the treatments which had received compost. Those were both organic treatments and biodynamic. The compost, provided it was well-made compost, was beneficial in that case. Another question, sawdust wait a minute. Presumably, can sawdust, etc., help devigorate vines? And that's certainly true. One of the, two of the main factors in causing excess vigor in vines is water supply and nitrogen supply. And certainly, if you've got a very fertile soil, such as one that we worked on up in the King Valley in Victoria, which had a very high nitrogen mineralisation potential, using cover crop, for example, as a grass cover crop, and also restricting water supply could help to control vigor. We didn't have a sawdust test, but certainly sawdust would mop up mineral nitrogen, and therefore it could reduce the vigor of the vines if that site was too high in nitrogen supplying power.
Okay, thanks very much for going through those final couple of questions, Robert. Looks like that's it with regard to the Q&A for today. So we'll start to wrap up. Firstly, thank you very much to Professor Robert White for presenting today. Thank you also to everyone who attended and took part in the session. For attendees, you will receive a follow-up email with a link to this recording and a link to a survey. Now, should you need to follow up on anything, please feel free to contact the AWRI directly. Robert did mention a number of research papers in his presentation. If you need to get hold or would like to get hold of any of these resources, please contact the AWRI library. You can do that via email or by phone. Next week's webinar is presented by Barbara Hall, Senior Research Scientist at South Australian Research and Development Institute, or SARDI, and the topic is Understanding Fungicide Resistance in Australian Vineyards. Now, if you haven't already registered for this webinar, please visit the AWRI website to do so. But once again, thank you for joining us today, and please do check out the AWRI's webinar program to register for future sessions.